Hello everyone and welcome to the lecture on kubectl node commands. So first we'll set the alias k equal to kubectl. So the first command is list all nodes in the cluster. So k get no. No is short form for nodes. So this command displays a list of all nodes in your Kubernetes cluster with basic information like name, status, roles, age and version. Use this command when you need to quickly check the status of all nodes or as a first step in troubleshooting cluster issues. So you will get output like this. There will be 5 columns: name, status, roles, age and version. So name of the node, what is the status, ready or not? What is the role? So this is the control plane node. What is the age? So say this is 70 days. And what is the Kubernetes version? Next command, display detailed information about all nodes. So you can type in k get no and output dash o white flag. So dash o output white flag provides detailed information about output about nodes, including external IP addresses, operating system images, kernel versions, and container runtime. Use this command when you need additional node infra details without the verbosity of a full description. So you have name, status, roles, age, which we have seen. Then there is additional columns like internal IP, external IP, operating system image, kernel version, and container runtime. So if I take this output, so you have this is the Kubernetes version. Then you have internal IP, external IP, whether if it is assigned or not. So it will show none or whatever is the external IP. Then Ubuntu and operating system image. What is the operating system version? And then what is the container runtime? So this is container D. Next, get detailed description of a specific node. So k describe no and followed by the node name. So this command provides comprehensive information about a specific node, including its conditions, capacity, allocatable resources, system information, recent events. Use it when troubleshooting node-specific issues or when you need detailed information about a node's current state. So you have the complete information: name, roles, labels, annotations, any tails are there or not, and all the other data, metadata. And if you just scroll down, any kind of addresses like internal IP, host name, and CPU capacity, all those information will be available, like how much is the allocatable and all, and system information. And then you will have like some more information, any kind of events that has happened on that particular node, and the events also. Next command is to show labels on all nodes. So k get no and dash dash show labels. So Kubernetes network policies use label selectors to control traffic flow between pods, and a misconfigured or missing label on a pod or the node it resides on can render a network policy ineffective. So you can check what all the nodes has got labels, and based on that you can troubleshoot better. So you will get, so along with the first 5 columns which we have seen, you have a labels column also. And for example, I'll just take worker node 2 and it has like disk type is equal to HDD, and this one has disk type SSD. So this is how you will check out the labels on a node. Next is to list nodes with a specific label. So for this we will use k get no and we will use a label selector. So dash L disk type equal to SSD. So this command lists nodes with a specific label. Use it when you need to identify and operate on a subset of nodes that share specific characteristics defined by labels. So we will only get back nodes which has this particular label. Get all nodes that are not control plane nodes. So these are all the worker nodes. So k get no dash L, and this one you have to remember, or this can be used in your work, day-to-day work and day-to-day projects. So you can say node role Kubernetes IO control plane. So this is the label and not equal to. So basically worker nodes will not have any label. So if you say not equal to and not followed by any just empty, then it will show all the worker nodes. So this command lists all nodes that are not control plane nodes. Use it when you need to identify and operate on a subset of nodes that are not control plane nodes. So you will see all the nodes which are not, the role is not the control plane. Get all events specifically for node 1. So let's say you want to find out all the events that has happened on a node 1. So k get EV. EV is short form for events. Field sector then you will say involved object dot kind. So this has to be node, and there one more condition, comma, involved object node equal to node name. So node 01. So this command gets all events specifically for node 01. Use it when you need to identify and operate on a subset of events that are specifically for a particular node. So this will give out, it will display all the events for node 1. So you'll see like last seen, type, reason, object, message. So for example, this is from the oldest to the newest. So 2 minutes 10 seconds ago, 2 minutes 10 seconds, 2 minutes 2 minutes, and finally 5 seconds. And for example, I'll just try to explain what this output tells us, that this output is time ordered log of everything significant that has happened to node 1 from perspective of Kubernetes control plane. Initial starting and not node ready even show when the node was successfully joined the cluster. The warning, eviction threshold met. So there's a eviction threshold met here. Eviction threshold met 30 seconds ago is very important event. It indicates the node's disk or memory usage was too high and kubelet tried to free up resources. A process called node pressure eviction. The subsequent node has no disk pressure event shows that the node recovered or the pressure temporarily subsided. Get only warning events for node 1. So you can add one more additional field selector. So field selector, we have seen this part, comma, type equal to warning. So this command gets only warning events for node 01 and use it when you need to identify and operate on a subset of events that are specific for a particular node. So you will get only warning messages. So we are seeing this warning messages. And this is slightly different example. So this, for example, the filtered output is a high priority list of problems that have occurred on node 01. So we have seen eviction threshold met. So this is a recent warning indicating node is running low on disk space or memory, invalid disk capacity. So this is the one which is shown here. An older warning that might indicate a storage configuration issue that happened earlier, and system out of memory error. So a critical event from 15 minutes ago. So here it tells you the node's Linux kernel ran out of memory and had to kill a process. In this case, a process named myapp. Get node resource usage statistics. So you can say ktop no. So it's similar to Linux top command. This command gets node resource usage statistics. Use it when you need to understand the resource usage of the nodes in your cluster. So you will get all the nodes and what is the how many CPU cores, CPU percentage, memory bytes and memory percent. So for example, control plane, there are 355 milli cores. What is the CPU percentage? 8%. How much memory is being used? So this is 3123 megabytes. And what is the memory percentage? It's using 39%, sorry. Find the node using the most memory. So you will use ktop no sort by memory. So this command finds the node using the most memory. Use it when you need to identify the node that is using the most memory in your cluster. So it will list from sort by memory. So whichever has the highest amount of memory. So 57%, 39% and 11%. And these numbers are like this is the highest and second highest and third highest. Find the node using the most CPU. So you will use ktop no sort by CPU. This command finds a node using the most CPU. Use it when you need to identify the node that is using the most CPU in your cluster. And same thing, but it is now ordered by CPU percentage. Mark a node as unschedulable. So you will say k-codon node name. Before performing maintenance on a node such as kernel upgrade, hardware change or kubelet update, it must first be isolated from Kubernetes scheduler. The codon command marks a node as unschedulable, preventing any new pods from being scheduled on it. Existing pods continue to run unaffected. So you will say k-codon followed by the node name. So you will get immediate output like this. It is codon. And if you do k get nodes again, so notice that the new scheduling nodes status on the worker nodes. So you will see scheduling disabled. So no new pods can be scheduled. Existing will run unaffected. Next is to drain a command. So first we'll cordon and then we'll do a drain. So kdrain and node name. So the drain command is rarely used without. So I'll just come to this. So this command is used always with some more extra flags. So it's rarely used without flags in real world or exam scenarios also. Understanding its flag is critical as omitting them will often cause the command to fail or hang. And so this is the actual command. So you'll say kdrain node name, and you will have these flags which you will use most of the time. Ignore daemon sets, delete local data. So I'm using two flags, and these flags I'll explain. Ignore daemon sets. So when you use ignore daemon sets flag, the pods managed by a daemon set will not be evicted. They will be completely ignored and will continue running on the node. So we have daemon sets and they have, for example, some pods running. So they will be ignored and this command will continue. If we don't give this command, it will fail. So that's why we will always use this first flag. Next is to delete local data. So this flag is mandatory safety check. Pods often use empty dir for temporary local storage on the node itself. To prevent accidental loss of important data, kubectl drain will refuse to evict these pods by default. By adding this flag, you are confirming that the data in any empty dir volume is disposable and can be permanently erased. So we add the second flag, and there is a third flag --force. So this flag overrides the default safety checks and forcibly evicts pod that are not managed by replication controller. So there are three replication controller: deployment, stateful set, or replica set. So these pods are created. So for example, unmanaged pod. So these are managed pod because they are controlled by these three objects. But sometimes we do a kubectl run direct, right? Or we kubectl apply, which has a pod definition. So normally drain avoids these bare pods because they won't be automatically rescheduled anywhere else. So in those situations, you will use --force flag also. And --force will delete these pods without respecting graceful shutdown periods and should only be used when you are sure that these pods can be safely terminated. So for example, you ran this command and there's some issue. You will get a message saying that it is cordon first, then evicting pod, and some pod will get stuck. So this is the successful condition. So if it is perfectly working, it's fine. But the failure condition, if there is a bare pod, like you have run a kubectl nginx pod direct, then the command will fail. You will get a message saying that unable to drain, and there are pending pods. There are pending pods when an error occurred. Cannot evict pod. So what is the pod name? Because it is not managed by a replication controller. So if you get this message, you just press the arrow key and you add the --force flag, and then so kdrain, again same command. I'm just repeating it, and I'm just adding the last --force flag. Restoring a node to a service. So we have drain, we have cordon. Now we are restoring a node back to service. So we'll say uncordon and the node name. So it removes the unschedulable status from a node, and that allows Kubernetes scheduler to resume placing new pods onto it. So this is the final step after you have completed maintenance on a node and are ready to return it to normal service. So uncordon and node name. So you'll get uncordon. So this is one upgrade workflow for the certified Kubernetes admin exam. So basically you will say cordon first and then isolate the node. You will say kdrain and you will say, let's say, ignore daemon sets, and this will evict existing workloads. Now you will SSH to worker node. So you are in different node. Now you will go to worker node. Then you will do apt-get update. Then apt-get install. This is the kubelet, the latest version, for example. Then you will do a system ctl daemon reload, restart, exit. Then you will go back to the first control plane node and you perform the upgrade. So you basically we have connected to worker node itself to perform software update. And now if I do a kget no, So verify the update from the control plane. Check the node has rejoined the cluster and is reporting the newer version. So first you will do uncordon and return node to service. So once the version is confirmed and the node is ready, uncordon it to allow the new workloads. And after this command, right, uncordon, it will be this command will tell okay whether this you can see 1.34 or not. And then if you see okay it's fine, then you will just say uncordon. So basically it's now ready to take new pods, deployments or stateful sets. Add a label to a node. So k label no node name and the key value pair. So the most straightforward mechanism for controlling pod placement is through node labels and node selector field. Labels are key value pairs attached to nodes that can be used to identify them for scheduling purposes. So key label no node name and disk type equal to SSD. So example, label a node as having a fast SSD. So this is the example. So you will get an output saying that it's labeled. And the backend YAML, for example, node, you can check out the YAML also if you want. So you will just have this new label. And these are the out of the box labels. And if you want to overwrite existing labels, you can have to put dash overwrite. So disk type, so let's say we want to overwrite this one, right? So disk type NVMe and overwrite. It will say okay, it has labeled again. So just same message. And if you want to remove label node disk type, so just a minus sign. Minus sign is for removing a key. So disk type we have removed. And it will say unlabeled. Adding a taint to a node. So k taint no followed by the node name, key value. So same like label, key value, but it is followed by a colon and the effect. So there are three effects that I will talk about. There are three taint effects. First one is no schedulable. So no new pod will be scheduled on a tainted node unless it has a matching toleration. Pods already running on the node are not affected. Second effect is prefer no schedule. So this is a soft version of no schedule. Scheduler will try to avoid placing a pod on the node, but it is not a strict requirement. It's a flexible requirement. Only if other things fail, then it will come to prefer no schedule. Last one is no execute. So this is the strongest effect. No new pods will be scheduled on the node, and any pods already running on the node that do not tolerate the taint will be evicted. So this is the most strong. So no new and existing will also be evicted one by one. So let's say what is the actual command, k taint no and let's say node name. So this is a taint app and the value app. So this is completely user defined and the effect is no schedule. So you will get an output saying that it is tainted. Remove a taint from a node is k taint no node name and for example maintenance. So this is only we need key because we don't need the value, and I am removing this no schedule effect on this node. So this command removes the specified taint from a node using the minus sign suffix. Use it to restore general scheduling capabilities to previously tainted node, and that allows more pods to be scheduled. So you'll get a message saying that untainted. Add an annotation. So we have something called annotation also. So k annotate node no and node name key value. Annotations are another form of key value metadata that can be attached to nodes. The crucial difference between labels and annotations is their purpose. Labels are for identifying and selecting objects, while annotations are for attaching arbitrary, non-identifying metadata, often for consumption by external tools, controllers, or for human readable nodes. Example. So we are adding a physical location. So basically, based on that, we can the developers will know where it's located. So annotate no node 01 asset tag, and we have provided an asset tag. So there is no technical use case that is part of it. It's just that we are conveying a message for other persons in the team that where is this is located. Technically, Kubernetes will not take any action based on the annotation. Immediate output, it will say annotated. Remove an annotation, so similar pattern, k annotate, node name, and whatever was the key, just minus sign. This will remove an annotation, and it will just say annotated. Watch node status changes, so k get no and dash w only one, or dash dash watch. So dash dash watch continuously monitors and display node status changes in real time. Use this during maintenance, scaling events, or when troubleshooting node issues to see immediate feedback as conditions change. So for example, this node 1, 2, 3, and for example 3, first it was in ready state, then it went not ready and ready. So probably let's say we have done some maintenance or something on by going to node 3. On the first node, I'll see how is the events being generated. List nodes by role. So k get no, again label sector. So I'm just saying node role Kubernetes IO control plane equal to, and I want to see all the roles. So this command filters and displays only the control plane nodes in your cluster. Identifying these nodes is important for maintenance planning, ensuring high availability and addressing specific security requirements. So this will list only the control plane master node, I can say. Filter pods running on a specific node. So k get pods, all namespaces. So I'm saying I want to list all the pods that are running on a specific node. Field sector, I'm saying spec.node name and followed by the node name, actual node name. So this command lists all pods across all namespaces that are scheduled on a specific node. Use it when planning node maintenance or investigating node performance issues to understand which workloads will be affected. So let's say I want to upgrade node 02. I just want to make sure that what pods are running before I make an upgrade. So you'll get a list of all the pods. And there's a namespace first and name, ready, status, restarts, and age. But this information is about the pods. Check system pods on a node. So we are checking system pods. So k get pods. Namespace is kube system. So because there are system pods. Field sector, we are saying spec and node name. So now we are just narrowing down the previous command. So this command lists system pods running on specific node in the kube system namespace. Use it when troubleshooting critical cluster services or assessing the impact of node failures on core Kubernetes components. So you will see, so here we don't have namespace column because we have already given over here, and these are all the system pods and they are all running on node 02. Drain node with pod grace period. So we can drain, but we can provide a grace period also. K drain node name, grace period 60 seconds. And we are saying ignore daemons, that we will always use this flag. So this command evicts pods from a node with a specific grace period in seconds before termination. Use it for stateful applications that need time to flush data to disk or complete in progress transactions before shutdown. So we'll get a message saying that okay, cordon, and it will just start evicting pods. It will just give us 60 seconds window to do a cleanup or the drain. Add multiple taints to a node. So you can add multiple taints also same time. So k taint no node, and this is the first one, maintenance 2, and this is no schedule, one more. So there's a space actually after this. So this is GPU enabled, so key value and no execute. So this command adds multiple taints to a node in a single operation with different effects. So no schedule and no execute. So we will get a message saying that tainted. And that's all. Thanks for watching.